In the last video, we extracted the information from the database using a query to map the number of different material classes within the burials of different sexes. And the result was this pivot table, this cross-tabulation here, and this chart. And from that chart, we saw that the number of amber objects in the female burials were much higher than in case of the male burials. But the question is this really due to a preference of amber in female burials, or is it just because we have much lesser male burials than we have female burials? So is there really a pattern in the data indicating that amber is more a female grave good, or is it just because of the sampling effect that we have by chance more female than male burials here in our dataset? To check this, we can use a statistical test. I will not go into detail here of the background of statistical testing in general, and also not of the specific statistical test. We will use a chi-square test here, and we'll just show you the technical details for doing so. Chi-square is, okay, bit of background. Chi-square is a test that evaluates the observed values against expected values given a uniform distribution of the values or an independence between two different variables. And if the observed values deviate strongly from the expected values, using in the background statistical distribution or measurement called chi-square, then the test assumes or shows that there is a significant deviation from independent situation, so that we have to assume that there's a pattern there. The statistical value or this statistical significance is expressed in the p-value. And the p-value is represented in that way that if it represents in a way the probability that the independence might be there. So if it is very low value, it means that there is little evidence for an independence, or the other way around, that there is quite an evidence for dependence. Or put it practically, if the p-value is below 0.05, we speak about a statistical significant pattern there, and then we have gained information about our cases here. Okay, we will do that here with our materials, and we will select the female and the male category and the information about amber there. So when we look to the table, we see that we have 30 sites, female sites with amber, and 30 items of amber in female burials and 2 items in male burials. We also need a background, so how many items in general are there. And we have the total numbers here actually, so we have 130 items in total in female burials, while we have only 15 items in male burials. So we have to express these informations in a way that we say this is amber, this is total. We will not use that later on, but this is no amber, so or non-amber burial items. And these are the females and these are the males. So to calculate the number of burial items that are not out of amber, we have to subtract this value of the items that are of amber from the total number. We can do that either by hand, or we can use the spreadsheet software because it's designed to do such calculations. So I press the equal or enter the equal sign, then say the content of this column minus the content of that column, and then we have this calculation done here, and I can just copy and paste this cell over here, and then I have the same for these cells here. Okay. Now we also need to come up with the expectation values. We need also the other total numbers here, which are called marginal sums of these datas. So to have an information how many Amber items we have in total, we can, or we should select the cell here and say sum of these two cells, and close the bracket again, and again we can copy this cell down below, and now we see we have our 128 total amount of Amber items in male or female burials, and we have 32 Amber items and 96 non-Amber items, while we have 113 female burials and 15 male burials, and both sums up to 128. So this is the total amount of items that we have in our data set that we are using for the statistical test. These are the observed values. Now we need to calculate the expected values. And we do that by using these marginal sums here. I had a bit of difficulties to explain why this is necessary, or why this is useful to have an idea about the situation when these two variables would be independent. So when the amount of Amber would be independent from if it's a male or female burial. I try it again. Maybe in this video it will be easier to understand. So we have a fixed number of male and female burials, and we have a fixed number of Amber and non-Amber objects. If the occurrence of Amber in male or female burials would not matter if it's actually male or female, the total Amber objects should be distributed to male and female burials like the total data set, like all the other data. And it's the same with no Amber. So if they are independent from male or female burials, they should be distributed like the total data set, like all the data, like if it's Amber or not Amber. For example, and this is not in this data here, but this is just a thought example, if we have half the sites with half the graves, half the objects out of Amber, and the other half out of not Amber. And the female burials also, half of all the female burials should be out of Amber, and the other half should be out of not Amber, of different materials. And the same at the male burials, so half of them should be out of Amber and the other half should be out of a different material. That's why we have to use these ratios of Amber to not Amber and the total amount of male burials, and distribute the total amount of male burials by the ratio between Amber and not Amber, so that in the individual cells the ratio is reflected, taking into account how many male burials we have in total. That's why we have to use these marginal sums here. So I just decorate my expectation table here, and then I start calculating. For the females, if it's Amber, the total amount that we expect for female Amber burials is equal to the total amount of Amber times the total amount of female burials divided by the total amount of artifacts in general. And the amount of female burials with other items of Amber is defined by the total amount of artifacts out of a different material than Amber times the total amount of female burials that we have, again divided by the total amount of items that we have in general. And the same is true for the male burials, only that we have to shift one column. So the total amount of male items out of Amber is defined by the total amount of Amber times the total amount of the male burials, again divided by the total amount of items in general, and also here it is equivalent to that. So these are the values that we would expect if there is no relationship between the category amber or no amber and male or female burials. And you can already see that these numbers are quite close to the numbers that we actually observed. So there's not so much difference, which means already in the first place, although we see quite a difference here, it probably reflects more the fact that we have very few few male burials in general. But to have a statistical investigation of that, we have to use the statistical test, and that's the chi-square test. To start that here, I have to again start with an equation sign and then type chi-test, and I open the bracket, and then it asks me to give the observed values first and then the expected values in a second step. So our observed values are these here. I add a comma, and now I have to enter the expected values, and these are those here. I can close the bracket, and now I can see 0.266 something. This is much higher than 0.05, which means there is no pattern detectable in a statistical sense that deviates from a uniform or equal distribution of amber to male and female burials, and the other way around, of male and female burials towards amber or no amber artifacts. So the differences between the expected values and the observed values are quite small, and we can't see any difference here. If I, for example, increase the values of amber at the female graves here, to put it to 80, since we have a fixed total number, the no amber number decreases to 33. This also results in that our expected values are changed. So now we have 82 objects of amber in total, which results in a recalculation of the expected values, and now we would expect 72 amber items in the female burials and 40 items of not of amber here. And especially in the male case, there is a huge difference. Now we would expect, because we have overwhelming amount of amber items here, we would expect that we have 9.6 amber items in the male burials, while we have observed only 2. And we would expect 5 non-amber items, while we have observed 13. And this results in a strongly changed p-value. Now this p-value is very small. It means 5 zeros leading and then 1 3 something, so 0.000001 3, and this means it's far below 0.05, and this also means that it's a significant result. So if we have this distribution, then we would see a significant preference of amber in respect to female burials. But this is not the case. These are our real values, and so we have not a significant result here in our case. That was it for now, and in the next video I will show you how we can perform a correspondence analysis using our data and the small online Tosca tool.